Neanderthals thrived across Europe and Asia for hundreds of thousands of years. Then they vanished. Archaeologists still debate why. 60,000 years ago, Earth's climate turned warm but wildly unstable. Cold snaps could last 1,000 years, then vanish overnight. Neanderthals used this warm window to spread further than they ever had before. It was their golden age. Their range stretched from France in the west all the way to Siberia in the east. They dominated a continent. Yet by 37,000 years ago, they vanished completely from the archaeological record. No more tools, no more bones. Something erased an entire branch of humanity in just a few thousand years. The question is, what? Events this ancient resist easy certainty. But three main suspects stand out from the evidence. Suspect number one, a shift in punishing climate that kept changing the rules of survival. Suspect number two, a flaw hidden within Neanderthal biology itself. Something that made them less adaptable. Suspect number three, us, Homo sapiens, arriving on their doorstep with new tools and new ideas.
But first, the elephant in the room. Did we actually breed with them? The answer is yes, and the evidence is in our DNA. Genetic evidence shows interbreeding happened on 3 separate occasions. The main event was around 60,000 years ago. The main event, where most of our shared Neanderthal DNA comes from, happened around 60,000 years ago. 2 smaller, fainter interbreeding events happened too, but they left barely a trace in our genes. One of those faint traces dates back over 100,000 years, long before the main mixing. Another more recent one happened after Homo sapiens had already pushed into Europe. Even so, calling it an extinction still holds up. Over 90% of our DNA traces back to Homo sapiens that evolved in Africa. The Neanderthal body type itself no longer exists anywhere on Earth. So were Neanderthals a separate species or just a different shape of human?
Either way, the slim, tall-brained Homo sapiens body won out in the end. The Neanderthal experiment, in a sense, simply came to an end. We still don't fully know what Neanderthal DNA does inside us. It may sharpen our immune system, giving us extra resistance to disease. Otherwise, evolution would likely have weeded that DNA out entirely. If it only caused harm, natural selection would have erased it long ago. But it also raises our risk of type 2 diabetes, a strange trade-off from a Stone Age inheritance. That trait may once have helped Neanderthals survive starvation and hardship, a metabolic advantage in lean times. In a world of easy fast food, that old survival trick backfires, turning a once useful gene into a liability. Which brings us to suspect 1, the climate itself. The environment may have dealt Neanderthals a losing hand. Around 60,000 years ago, temperatures resembled today's, but far less stable, swinging wildly between warm and cold. Cold snaps during this era could drag on for 1,000 years, a single generation of ice that lasted longer than any empire. That kind of instability puts brutal stress on any population. Food becomes scarce, shelter harder to find, and survival a daily gamble. Most large animals actually rode out these swings and survived. Mammoths, woolly rhinos, and bison all made it through. But some, like the straight-tusked elephant, went extinct anyway, a creature that once roamed the same European forests as Neanderthals. So did Merck's rhinoceros, a giant of the same forests, another heavyweight that couldn't adapt fast enough. Did Neanderthals share the same fragile habitat as these lost giants, and face the same fate when that habitat collapsed? Then, 39,000 years ago, a volcano erupted in southern Italy, near what is now the Bay of Pozzuoli. That eruption blasted ash so high and so far that it drifted all the way to Asia. At archaeological sites across Europe, that single ash layer forms a clear dividing line between Neanderthal remains below and human remains above. Right after the eruption, the climate took another hit. Massive glaciers broke off from the Arctic ice sheet in a Heinrich event. That glacial collapse dragged global temperatures down even further, locking the continent in a prolonged cold snap. Living through both disasters back to back, a volcanic winter followed by a glacial surge, would have been brutal for any population. Was this 1-2 punch from the volcano and the Heinrich event the final nail in the Neanderthal coffin? Any trace of Neanderthals surviving after that eruption is fiercely disputed among archaeologists. Even so, a change in climate alone doesn't explain everything. Neanderthals had weathered ice ages before. Why didn't Neanderthals simply adapt the way we always have? After all, humans went on to dominate nearly every climate on Earth, from the tropics to the Arctic. So if Neanderthals had survived previous climate shifts, what made this one different? So was there something inside Neanderthals themselves that blocked adaptation, no matter how hard the climate pushed? Neanderthals matured faster and died younger than we do. A 12-year-old Neanderthal was as developed as a 16-year-old Homo sapiens. One skeleton from La Moustier in France showed exactly that. A Neanderthal child who at 12 had the bone development of a 16-year-old modern human. Very few Neanderthals appear to have lived past 40. Their life expectancy was brutally short by our standards. Shorter lives meant less time to learn, less time to pass on knowledge, and less opportunity to innovate. Their stocky frames demanded roughly double the calories a modern human needs, a huge metabolic burden. That is a brutal cost when your habitat shrinks or your preferred prey disappears. As the climate cooled near 37,000 years ago, the dense forests that Neanderthals favoured began to retreat. Open grasslands spread in where dense forest once stood, a completely different world. A stocky, forest-built Neanderthal body was ill-suited to that new grassland. Short legs, heavy build, and high-calorie needs were now a disadvantage. Homo sapiens, built leaner and longer-limbed, may have handled the open plains far better, covering more ground with less energy. Under pressure, Neanderthals didn't spread out to find new opportunities. They retreated into core areas, shrinking their already small populations. That retreat squeezed Neanderthal populations into ever smaller pockets, like water pooling in the last hollows of a drying riverbed. With those shrinking populations came a hidden cost. Neanderthal genetic diversity was already far lower than ours, a warning sign that their numbers had been dangerously small for a long time. A single Neanderthal toe bone, found in Siberia's famous Denisova cave, reveals just how low that diversity had fallen. Analysis of that bone showed something shocking. That woman's parents were so closely related they may have been half-siblings. Inbreeding on a scale that signals a population in crisis. Across Europe, archaeological sites tell the same story. Neanderthal populations were already shrinking before modern humans ever set foot on the continent. Some regions go completely silent. No Neanderthal tools, no remains, no trace of their presence at all. Entire territories emptied out. Yet in France and Spain, the picture gets far messier. Here, the neat story of decline collides with a stubborn, complicated reality. In those regions, Neanderthals and modern humans appear to have overlapped for several thousand years, side by side sharing the same valleys and forests. So what role did we Homo sapiens actually play in their end? That question is the hardest one to answer, and the one that matters most. Modern humans reached Europe roughly 43,000 years ago, a date that marks the beginning of a new chapter and the end of an old one. They arrived carrying an entirely new kind of material culture, things Neanderthals had never seen, made from materials Neanderthals had never used. Bone tools, sophisticated art, carved sculpture, even early music came with them, a cultural toolkit that signaled a fundamentally different way of thinking about the world. This incoming culture, the Ornithian, preferred the same forested environments that Neanderthals had called home for millennia. So the question is straightforward. Did these newcomers simply outcompete Neanderthals for the same resources, the same deer, the same caves, the same gathering grounds? Could small bands of Neanderthals have simply joined these human groups, interbreeding and gradually being absorbed until their distinct body type just faded away? It's genuinely hard to say. The archaeological record is patchy. We don't have enough sites from this period to know how often these groups actually crossed paths. Roughly one person lived per 100 square kilometers back then. That's about the size of a small modern city, with maybe a handful of people in it. At that density, meaningful contact between Neanderthals and modern humans may have been rare, a chance encounter every few generations, not a daily struggle. About 6,000 years after Homo sapiens first arrived in Europe, the last evidence of Neanderthals disappears from the archaeological record for good. That final disappearance coincides with the arrival of a new human culture, one that would prove even more adaptable to the rapidly cooling world. Archaeologists call this culture the Gravettian, named after the site of La Gravette in southwestern France, where their distinctive tools were first identified. Gravettian people were experts at surviving an increasingly cold, harsh climate. They didn't just endure the Ice Age, they thrived in it. They ate enormous amounts of fish from rivers and coastlines, salmon, trout, and even freshwater eels, a reliable food source that didn't migrate away in winter. They expanded along coastal routes, following the migration of herd animals and the bounty of the sea, as the climate kept shifting beneath their feet. The Gravettians didn't just survive the cold, they tracked the seasonal migration routes of herd animals with precision, following reindeer and bison as they moved across the landscape. They also wove nets from plant fibers and sinew, not just for fishing, but specifically to trap small mammals like rabbits, a steady food source that didn't require chasing dangerous prey. These weren't just survival tricks. The Gravettians actually thrived in the cold, their population expanding across Europe while Neanderthal numbers shrank. So is this wave of adaptable humans the true final blow to Neanderthals? It's a question that haunts every archaeologist working on this puzzle. Homo sapiens kept expanding right when Neanderthals were at their weakest, a demographic pressure that would have been devastating for any population already on the edge. It's impossible to say for certain from the evidence alone. The archaeological record is too patchy, the timeline's too blurry, and the gap's too wide. But if Neanderthals weren't already extinct by the time the Gravettians arrived, their numbers were vanishingly small, maybe just a few hundred individuals scattered across isolated pockets. In truth, all three suspects, the climate, internal flaws, and Homo sapiens, probably share the blame, working together in a perfect storm that the Neanderthals couldn't survive. Shifting climate forced Neanderthals into smaller and smaller core territories. The forests they depended on were replaced by open grasslands they weren't built for. That retreat opened a gap in the landscape, an ecological vacuum that the more adaptable Homo sapiens were perfectly positioned to exploit. Once pushed that far back, Neanderthal populations simply couldn't bounce back. Their low numbers, inbreeding, and slow reproduction made recovery impossible. Some Neanderthals likely joined human groups, absorbed into our lineage through interbreeding, carrying a whisper of their ancient DNA into every one of us today. Others simply died out, leaving no descendants of their own. Their line ended in silence. Their story ends not with a single blow, but a slow, layered collapse, 1,000 small pressures piling up over millennia. Climate, biology, and competition each chipped away until nothing was left, like a tree stripped branch by branch. Their DNA still lingers faintly inside nearly everyone alive today. A ghost in the genome, a whisper from a lost world, a trace of an immune system trick they once relied on, a hidden gift that helps us fight off diseases we never knew we'd face, a trace of a diabetes risk born from ancient starvation survival, a metabolic leftover that helped them through lean winters but haunts us in the age of fast food, proof that Neanderthals never fully vanished. They were partly absorbed, their blood mixed with ours, their story woven into our own. Their story is less an ending than a quiet, incomplete merger, two rivers that met then flowed on as one. The same volcano that split the record still shapes what we know. It's ash a timestamp that forces us to ask what came before and what after. The same ash layer that divided Europe now divides our timelines, a razor-thin line between the world of Neanderthals and the world of modern humans. Every skeleton, every toe bone, every scrap of DNA adds one more clue, and each clue narrows the gap between what we know and what we don't. And every clue still leaves room for real scientific disagreement, because the past, like a good mystery, keeps some of its secrets to itself. And that uncertainty, that fog of incomplete evidence, is precisely what keeps the Neanderthal extinction alive as a mystery worth chasing. Because 60,000 years of shared history of interbreeding, of overlapping territories, of climate chaos, left almost no clean answers behind. The Neanderthals, who once ranged from the caves of France to the frozen steppes of Siberia, are gone. Their body type, their culture, their entire experiment erased from the living world. What's left of them survives scattered across our own genome, about 2% in most non-Africans, a living fossil hidden inside every cell. A 12-year-old Neanderthal, recovered from Le Moustier in France, was as physically developed as a 16-year-old Homo sapiens, a childhood cut short by evolution's clock. A grandmother's toe bone found in Denisova Cave in Siberia revealed generations of forced inbreeding. Her parents were so closely related they may have been half-siblings. A volcanic ash layer from an eruption in southern Italy 39,000 years ago marks the last shared chapter of two human lineages, Neanderthal below, Homo sapiens above. A net woven by Gravettian hands from plant fibers twisted into cordage helped them catch rabbits and small game, a technology Neanderthals never mastered at scale. None of these clues alone explains the ending, the ash, the inbreeding, the childhood cut short, the missing nets. But together they form a picture that begins to make sense. The climate turned the world against them slowly, not all at once, forest giving way to grassland, their preferred prey vanishing, the cold biting harder with each millennium. Their own biology gave them less room to bend than we had. Shorter lives, slower reproduction, a body that demanded double the calories just to survive a single day, and we simply kept expanding into the space they left behind, not as conquerors, but as survivors who happened to be standing when the music stopped. 3 suspects: climate, internal flaws, and competition from us. But no single culprit has ever been convicted. The case file on the Neanderthal extinction remains open, precisely because all 3 factors work together, not alone. Modern humans didn't need to fight Neanderthals to outlast them. The evidence shows no battlefields, no mass graves from warfare. Instead, we simply occupied the same landscapes more efficiently, taking the resources Neanderthals depended on, without ever raising a spear. Sometimes surviving simply means adapting fractionally faster than your rival. In the Ice Age, a few degrees of temperature shift, a change in prey migration patterns, or a new tool-making technique could tip the balance. Neanderthals adapted slowly, humans adapted quickly. The Gravettian net and the human fishing line prove that point. While Neanderthals hunted the same big game, mammoths, bison, humans started catching rabbits with nets and salmon with hooks. Small, reliable calories beat big, risky ones every time. While Neanderthals retreated to their strongholds, the caves of southern France, the forests of Iberia, Homo sapiens kept spreading. We followed coastlines, river valleys, and animal migration routes. Every new territory we entered, Neanderthals left or died. That single difference in strategy may have decided the entire outcome. Neanderthals hunkered down and hoped conditions would improve. Humans moved, adapted, and spread. In a world where the climate was changing every few generations, mobility was a superpower. Extinction, in this case, looks less like a war and more like erosion. Not a single cataclysm, but the slow wearing away of a population until nothing remained. One group couldn't find enough food, another couldn't find mates, a third felt a disease. A little climate stress here, a little competition there, and the numbers just add up. Neanderthal populations were already small and inbred by the time modern humans arrived. Any extra pressure, a bad winter, a failed hunt, a new disease, could push a local group over the edge. Over thousands of years, that erosion left no Neanderthals standing. The last confirmed Neanderthal remains date to about 37,000 years ago. After that, the archaeological record shows only modern humans. The Neanderthal body type, short, stocky, powerful, simply vanished from the earth. Yet erosion isn't erasure. Some of them live on inside us. Every person of non-African descent carries between 1 and 2% Neanderthal DNA. That's not a metaphor, it's a biological fact, written into our genome. They didn't vanish completely, they merged. Every time modern medicine studies immune resistance, their legacy resurfaces. Neanderthal DNA boosts our ability to fight off certain viruses and bacteria. Those ancient genes, inherited from a few encounters 60,000 years ago, still protect us from infections today. Every time researchers study type 2 diabetes risk, their legacy resurfaces. The same Neanderthal genes that helped our ancestors survive starvation now increase our risk of metabolic disease. A gift from the past that doesn't always fit the present. A living reminder that evolution never stops. Neanderthals are not just a chapter in a textbook, they are, quite literally, partly us. Every person with non-African ancestry carries between 1 and 2% Neanderthal DNA woven into our genome like invisible threads from a distant cousin. That reframes the question entirely. It is no longer just why did they die, but what did we inherit, and what did we lose when their lineage faded. Their disappearance reshaped what it even means to be human today, because without them, our ancestors might never have developed the immune advantages, the cold weather adaptations, or the genetic diversity that helped us survive the last ice age. It is a stark reminder that even a successful, widespread species, one that had thrived for over 300,000 years, can still vanish. No empire, no technology, no population size guarantees permanence. Neanderthals survived cold snaps that would have wiped out many species. They adapted to shifting prey, from straight-tusked elephants to reindeer, and endured centuries of hardship before the final crisis hit. What finally broke them was not one single disaster, but a stack of small ones. A variable climate, shrinking forests, dwindling prey, inbreeding, and the arrival of a new competitor, each one manageable alone, but devastating together. And that pattern, slow accumulation followed by sudden collapse, echoes far beyond Neanderthals. It is the same story playing out in ecosystems, economies, and even empires today. This is exactly why the Neanderthal extinction has become one of the most fiercely debated questions in archaeology, because it touches on how fragile any species can be, even one that looks so much like us. Every new fossil find still has the power to shift the entire picture. A single bone from a cave in France or a tooth from Siberia can rewrite timelines, overturn theories, and force archaeologists back to the drawing board. The Denisova cave in Siberia alone continues to reveal fresh genetic surprises, including the toe bone of a Neanderthal woman so inbred her parents were likely half-siblings, a stark sign of just how small and isolated their populations had become. Even the volcanic ash layer from the Puzuli eruption, which blanketed Europe around 39,000 years ago, is still being studied for new clues, each grain of ash, a tiny time capsule holding microscopic evidence of what happened next. Each new excavation adds another piece to the puzzle, but rarely delivers a single clean answer. The Neanderthal story remains stubbornly, beautifully incomplete, a mystery that keeps us digging, keeps us wondering, and keeps us connected to our own ancient past. And that's exactly why this remains one of prehistory's most compelling stories, not because we have a tidy answer, but because every new fossil, every ancient DNA study forces us to rethink what we thought we knew about our own deep past. More Stone Age mysteries like this one are still waiting to be told, the first artists, the great migrations, the lost languages carved into bone and antler, and each one offers a new window into the world our ancestors actually lived in. This deep dive into human origins only scratches the surface of the era. The real story of the Stone Age spans hundreds of thousands of years, and every archaeological dig, every new radiocarbon date, adds another chapter we never saw coming. There's a whole prehistoric world of daily life still left to explore, how they cooked, how they mourned, how they passed down stories around fires that went cold 40,000 years ago, and each detail brings us closer to understanding the people who came before. If this pulled you in, more ancient history stories are just ahead. The first farmers, the first cities, the forgotten empires that rose and fell long before any written record, and Flint will be there to show you how it all really happened. The Neanderthals are gone, but their story, and ours, keeps unfolding. Every time a new fossil is found, every time a genome is sequenced, we learn a little more about the cousins who walked the same earth and the long road that led to us.